Hi XR developers, and welcome to a new MR Motif, which is our way of introducing development best practices to you as a recipe on how to create outstanding mixed reality experiences. In this tutorial, we're going to learn where and how the pass-through layer can and should be used, load our applications with contextual pass-through, as well as create and use a custom shader and script to smoothly transition between pass-through and VR for a seamless user experience. You can find all the assets for this project on our GitHub page. The link is in the description. And now, let's get started with pass-through transitioning. Enabling pass-through is easy, but there are two main scenarios where a separate logic is needed when using pass-through as the background of your experience: contextual pass-through and conditional pass-through. Contextual pass-through means if the user is in pass-through mode in his home environment, our operating system can detect this and use this information to display pass-through in our Unity app as well. We also call this "is pass-through recommended". Contextual pass-through is the new default, and we can see this by going to the System Splash Screen background option on the OVR Manager component in Unity. Here we can simply change the System Splash Screen background. We then also need to make sure that in the Unity project settings, Show Splash Screen is unchecked and that no texture is selected for the virtual reality splash screen to achieve an uninterrupted experience. Lastly, you will need to update the Android manifest file in your project. For this, you need to go to Meta, then Tools, and then update the Android manifest file. Keep in mind that unfortunately, this built-in splash screen can only be turned off with a Unity Pro license, and therefore, without it, the system splash screen background will still be black. One prime example of how to use contextual pass-through is Cubism. Cubism is primarily enjoyed in pass-through mode. Now, a user being in pass-through mode in his MetaQuest home environment can then load the app in pass-through mode and also continue to play in pass-through mode, without interruption to the user experience. Let's now move on to the core part of this tutorial, where we use a custom Passthrough Fader logic to switch between pass-through and VR at runtime. This is what we call conditional pass-through in this context, and it is commonly used when an experience has a mix of pass-through MR and immersive VR modes, and needs a way to smoothly transition between the two. A prime example of this is Whirl, which lets the user jump from a mixed reality tabletop experience into an immersive street view experience. Let's take our scene from before and look at the OVR pass-through layer. We need to set this layer to underlay. This means that pass-through appears in the background and we can place virtual objects in front of it. We also want to set the camera clear flags to solid color and make the background transparent on our main camera. On the OVR Manager, you want to make sure that pass-through is supported and the inside pass-through is enabled. Using the pass-through building block will automatically set all of this up for you. Now, the easiest and most performant way to switch between modes would be to simply enable or disable the OVR pass-through layer and change the clear flags and background color of our main camera back and forth whenever we want to switch the mode. However, we need to keep in mind that there is a short delay after enabling the pass-through layer in which the pass-through layer is still being initialized, which can lead to a black flicker. Therefore, we want to find a more elegant way of fading between the two modes. In this sample, we will use a sphere which sits on top of our main camera. By slowly fading the visibility of this sphere in and out, we can achieve a nice fading transition. So, let's create a simple sphere without a collider as a child of the center camera, or simply use our pass-through fader prefab from the GitHub project. On the mesh renderer, we will assign a material that comes from our pass-through fader shader. Let's look at how this shader works. You will notice that it is very similar to the Selective pass-through shader and has several properties. Most notably, we need an inverted alpha, which will determine the visibility of our sphere, and a direction which will later determine from which direction we will fade the material to achieve a smooth fade animation. By default, the shader's render queue is set to 2999, which makes it render right after transparent shaders. So we can fade behind any object without experiencing any set fading or flickering. Next, we want to disable backface culling, so we can see the circle's shader even if our camera is inside of it. A quick pro tip here: if you ever experience the issue in your editor or your MetaQuest headset where you only see an object rendered on one eye, make sure you don't forget to set Unity Vertex Input Instance ID, which is used in shaders to handle unique identifiers for instance rendering, and the Unity Vertex Output Stereo macro, which identifies the vertex shader output for stereo rendering to ensure correct visual outputs for each eye. Now, the vertex shader transforms vertex positions and texture coordinates, preparing for stereo rendering. The fragment shader adjusts the alpha channel of the texture's color based on the specified fade direction. These adjustments allow for effects like fading edges or creating transitions. The fade effect is implemented as a series of if-else statements that modify the alpha component of the color based on the texture coordinates and the fade direction property. Keep in mind, like with the selective pass-through shader, we use an inverted alpha scale here, meaning that at 1 the material is completely invisible and at 0 it is completely visible. The last piece we need to fade the pass-through is a script that manipulates these alpha and direction values. Let's start with a simple pass-through fader, which we call underlay in this case. The script starts by defining two private enums. The fade direction will tell our logic from which direction to fade from, and the fader state will keep track of if we are currently in pass-through or VR mode, or in transition between the two. Next, we have serialized fields for assigning our pass-through layer, setting the fade speed, determining the fade direction, and then we define 4 Unity events which notify us when the fade in and fade out have been started and completed. You can use those events to call other methods or simply play an audio clip. In the awake method, we fetch a reference to our main camera and cache its background color. Very importantly, we want to disable the pre-multiplied alpha mode, which will improve the visual quality of our blending between pass-through and virtual objects such as skyboxes. Next, we need a reference to the mesh renderer of our sphere and its material to later manipulate our shader. In the GitHub sample, we created a UI panel for you that contains a button to toggle between VR and pass-through. Therefore, we want to get a reference to this UI panel here and access its button. We subscribe to the onClick event to call our toggle pass-through method whenever the button has been clicked at runtime. Next, when we enable the pass-through layer at runtime, we need to wait a few milliseconds until it is ready, which we can do with this pass-through layer resumed event. We will call the onPassthrough layer resumed method whenever the event has been triggered. Next, we call the setup pass-through method, which fetches the camera's far clipping plane and scales our sphere big enough to contain the whole scene in it. When we are in pass-through mode, we would like to disable the mesh of the sphere, since we only need the sphere visible for the duration of the fade. We would also like to check if pass-through is recommended, as mentioned before when we talked about contextual pass-through. We check if pass-through is recommended and set the camera's clear flags, background color, as well as the alpha value accordingly, meaning the alpha value should be 1 if we are in pass-through and 0 when in VR. The pass-through layer is disabled when no contextual pass-through is detected, otherwise it is enabled by default in our scene. Next, whenever we want to toggle between pass-through and VR, we call the toggle pass-through method. In this method, we first call the update fade direction method to get the current direction the user has set in the inspector. Then, we enter a switch statement where we define 3 fader states: MR, VR, and in transition. If the alpha value of the material is 1, it means we are in the MR mode. Here, we first enable our sphere's mesh renderer and switch the camera's flags to skybox and background color. Next, we set our target alpha value to 0, invoke our event, which notifies us that the fade out is starting now, stop all ongoing coroutines, and then finally start the coroutine for fading back to VR mode. If the alpha value is already 0, this means our fader state is already VR, and we would like to enable the pass-through layer. Now, as we learned before, we now might have to wait for a few frames for the pass-through layer to resume, which invokes the onPassthrough layer resumed event. Here, we do the exact same thing, with the difference that we do not want to change the camera's flags and background color, and instead set the target value for the inverted alpha to 1. Last but not least, in the in transition mode, the alpha target is toggled between 0 and 1, based on which value the alpha is closest to. Depending on this new target, the corresponding event is triggered and the fade to target coroutine starts to fade to the new target. This in transition state allows us to gracefully catch if the user is toggling the state even though the last fade animation has not ended yet, in order to quickly change back to the other state. Finally, let's look at the method that actually fades our material. The fade to target method starts by retrieving the current inverted alpha value of the material. In a while loop, it incrementally moves the value towards the target value that was set by the toggle method. This loop continues until the difference between the current and the target alpha is close to 0. We use this approximation because in Unity, sometimes the float value is not exactly 0. In this case, we would end up in an endless loop, and with this approximation, we can prevent this. After exiting the loop, the method checks if the target alpha is close to 1, or in other words, we are fully in pass-through. If true, it sets the camera's clear flags to solid color and the background color to clear, and then invokes onFadeIn complete. Else, it must mean we are in VR mode, and we will disable the OVR pass-through layer, set the camera's clear flags and background color accordingly, and invoke the onFadeOut complete event. Finally, we disable the mesh renderer at the end of the method, since we are done fading. Now, we can attach this script to our sphere in the editor and assign our pass-through layer as well as configure our fade speed and direction. Then, we just need a way to call our toggle method. We can either use the UI panel that comes with the samples, or just use the controller button's mapper building block to quickly hook our method to a button on the controller. How you want to call this method is totally up to you. Let's just assign any button we like, and then reference our pass-through fader script on our sphere and call the toggle pass-through method from it. Let's finally give this a test. As you can see now, we can now easily implement a pass-through fader into any new or existing scene with no or very little adjustments. Another pro tip: while the boundary is an important safety system required for fully immersive apps, it can unnecessarily interrupt the user experience when in a mixed reality experience. We have two options here. We can go completely boundaryless or use the boundary API for contextual boundaryless apps. For safety reasons, boundaryless is not recommended for mixed reality apps with fully immersive elements in it. Therefore, we will set up contextual boundaryless, which means that our app will turn off the boundaries automatically when in pass-through and turn them back on when we switch back to VR. We can easily do this by going to our OVR manager and setting the boundary visibility support to supported or required. Further down, we want to check should boundary visibility be suppressed. For these changes to take effect, we need to update the Android manifest file once more, which we can do by going to Meta, then Tools, and then Update Android Manifest XML. If you now give the sample scene a try and are close to the boundary, you will see how it will turn off and on based on if the pass-through layer is active or not. Awesome! In the samples of this motif, you can also find another pass-through fader, which we call Selective. This fader lets you select the range, where only within this range we want to see the virtual content. This can be helpful for more specific use cases where you only want to see game object in a certain radius around the player. Before we wrap up this tutorial, let's talk about one last use case. Namely, we'd like to show you how to adjust the fader using a slider, which can be useful for experiences where you need a little bit more control. For this case, we prepared a script that is quite similar to our previous fader components. For the slider, we again have a selective distance, and this time we need to define a threshold as to where we would like to enable and disable the boundary, because we will never completely disable the pass-through layer and therefore never explicitly trigger the contextual boundaryless. We adjust the inverted alpha, pass-through layer, and mesh renderer directly in the awake method. We also set the sphere size and fade direction directly in the awake method. Instead of a toggle, we now look for a slider on our UI panel and subscribe to the onValueChanged event on the slider. When the slider value is being changed in our experience, we will call the handleSliderChange method. Then again, we want to check if pass-through is recommended. If so, we set the inverted alpha value to 1 and the slider value to 0. Else, we set the inverted alpha to 0 and the slider value to 1. Lastly, in the handleSliderChange method, we need to do some adjustments for the alpha value. We need to normalize the alpha value since our alpha scale is inverted. For this, we simply subtract the slider value from 1 to get a linear increase and decrease, except for the inside-out direction, which behaves differently to the other directions. Here we need a more drastic increase from the center and a more gentle fade on the edges, which is why we need a more specific formula. You can adjust these values to your liking. We can then apply this normalized value to our inverted alpha and check if we reached our boundary threshold. If we cross the threshold, we would like to not suppress the boundary, or in other words, make it visible. If it crosses the threshold from the opposite direction, we would like to suppress the boundary. Finally, let's give this slider a try. We can adjust the distance and threshold and then hit play. Amazing! You can now see how we can smoothly and incrementally adjust the pass-through fader as well as the ambient audio. You will also see how the boundaries get enabled and disabled as we adjust the value. In the samples, we provide you with even more exciting effects, such as these dissolve effects. We even give you one sample that uses an HLSL shader and one that uses a shader graph shader. Furthermore, all shaders work in URP as well as the built-in render pipeline. so everyone can find something for their project. Check out our GitHub project for more information on all the components and shaders in the project and how to configure the scenes. Great! Thank you so much for watching this tutorial all the way to the end. You can find this project with all the source code on GitHub. The link is in the description. Also, don't forget to check out our blog post about pass-through transitioning to get even more tips and details. Did you like this motif? Would you like to learn about more tips and tricks to bring your mixed reality experience to the next level? Let us know in the comments what other topics you want us to cover in the future, and stay tuned for new MR Motifs.